Right, okay, so starting at A. Oh, let me just rub that out. Hang on. Right, starting at A, two neighbours, B. So the cost to get to B is cost to A, which is 0, plus 5, which is better than infinity. So let's update. Parent is A. The other neighbour is I. So the cost to get to I is the cost to get to A, which is 0, plus the 3. That's better than infinity, so we update. Okay, what we must make sure we do is we close off the A because we visited it. Right, we then pick the cheapest cost, which is I. So we're going to pick I. We then look at its neighbours, where it's got a neighbour A, but that's in the closed set. It's been visited, so we ignore that. It's got a neighbour H. So the cost to get to H is 3 plus the 1. So that's better than infinity, so we update. Parent for that was I. We have got a neighbour G. So that's the cost to get to G is 7 plus 3, which is better than infinity, so we update. So that's 10 and I. So we now pick the next cheapest. So we look through the list in the open set, and that's going to be H. So let's close it. Look at its neighbours. I has been visited, so we ignore it. G, the cost to get to G is the cost to get to H, which is 4, plus the 2. So that's 6. That's better than the current cost, so we update that. And we say the parent for that was H. So I'm keeping track of the old values. Okay, you can see me working then. Right, so we've explored the neighbours of H. Let's go for the next cheapest. So the next cheapest in the open set is B. So let's select B. The neighbours of B are A, which is closed, so we'll ignore that. We've got C. So the cost to get to C is 5 plus 4, which is better than infinity. So let's write 9 down and put the parent as B. We've then got J. So we've got the cost to get to J is 5 plus 10. So that's 15, which is better than infinity. So let's update. Put the parent down as B. No other neighbours. So let's go around the process again. Pick the cheapest. So the cheapest currently, so we've got G. So we'll close G off straight away. Right, neighbours of G. I, which is in the closed set. Ignore it. Don't have to do anything. H, which is in the closed set, so we don't have to do anything. But it has actually got this other one, E. So let's work out the cost to E. So it's 4 plus the cost to G. Okay, so that's currently 6 is the best cost to G. So 6 plus 4 is 10. So E, the cost is better than infinity, and that was from G. It hasn't got any other neighbours, so we've finished now. So let's go pick the cheapest. So we'll look at the cheapest. It looks like C. So we'll pick C, close it off straight away, look at its neighbours. B is in the closed set, so we can ignore it. It's got another neighbour D. So that's in the open set, so let's have a look at that one. So we've got the cost to D is 10 plus whatever it costs to get to C. So that's going to make that 19, which is better than infinity. It's got another neighbour K. Okay, K's in the open set. It hasn't been crossed off. So the cost to get to K is 1 plus whatever it cost me to get to C. So that's going to cost me 10. So let's update that and put the parent as C. Now, we've done all the neighbours of C. Let's go around the loop again and do another Dijkstra loop. And we'll pick the smallest. So it isn't 19. We've got a 10 there. We've got a 15. And we've got another 10. Now, how you decide which one you pick doesn't really matter at the end of the day, but I'm going to pick the first one I came across, which was the E. So I'm going to put it in the closed set. Now the E is where we were going for, so we're now going to stop. We do not need to search any further. We could keep going and we could do the calculations for all of them, but we've just got there with a cheaper cost. Okay, so we're going to stop at this point. And then we're going to work backwards through the parents to find out what the root was. So the root for this one, so we arrive at E, but we got there. So we look at the parent of E, it was G. We look at the parent of G, which was H, and it's important that you've done the updates. We look at the parent of H, which was I. We look at the parent of I, which was A. We look at the parent of A, which is null, so that was the start location. So that is my route.